Okay, so there are two methods of formation of precipitation. One method is called coalescence, where small droplets that are falling through the clouds collide with other droplets, continuing to get bigger and bigger until they're large enough to completely fall to the surface without evaporating. The other method usually occurs in larger cumulonimbus clouds, where we have aggregation occurring, where we have the ice crystals, and they continually meet with one another and collect with very cold water droplets, and they continue to build on one another, and then these crystals eventually gain enough mass to fall to the surface. And we see different types of precipitation. We see rain from coalescence, and that is just water droplets that fall to the ground. We see sleet, where sleet is different, is that it is rain that falls from the cloud in a liquid form, but then it freezes into ice before it actually hits the ground. And then we have snow, which we all love snow, and snow is formed in these ice crystals when they're in the atmosphere. It has to be really cold in the upper atmosphere for them to freeze into ice crystals, and it has to stay cold enough as they fall down for them to stay frozen. Otherwise, they'll melt. And then lastly, we have hail, where hail works similar in these cumulonimbus clouds, where you have a large updraft that comes up, and that keeps really cold droplets of water and freezing ice crystals to continually get larger and larger by being pushed up by these updrafts until they're eventually just too heavy, and then the hail falls down to the surface. Next, we're going to talk about our different fronts here. We have a cold front. So the cold front's coming in here like this. We might have some warmer air that is present here. In your cold front, you're typically going to see more severe weather, more violent weather, especially here in Oklahoma, such as strong thunderstorms. Those are going to be kind of falling along on the head of the front. When you have a warm front, where you've already got that warm air present, or you've already got cold air present in the area, and you have warm air coming in, your cold air is here, and your cold air is being pushed out at the ground level. Typically, we see clear skies following these fronts, sometimes things like fog, but typically very peaceful skies. You'll have a stationary front, in which you might have two different types of fronts that are running alongside of each other. And ultimately here, that's kind of, they're muting themselves a bit. They're losing most of their characteristics that really define them. And so these fronts typically don't have a whole lot going on. You will typically see that the wind runs parallel with the front itself. So sometimes they say that cold fronts will stall whenever they're in a stationary state. Unless we have occluded fronts, and occluded fronts happen whenever you have a cold front and a warm front at the same time, but a cold front is faster. And so because the cold fronts are faster, that air will catch up with the warm air. And this often happens with late in the life of an already active storm system. And the weather on either side of the front typically tends to be much aligned with what you would normally expect out of a cold front or a warm front. Last, we're going to talk about the lifting of air. The lifting of air is important primarily because it is the concentration of moisture in the air, which in turn causes the formation of clouds and the release of precipitation. As we all know, that precipitation is extremely important to making sure that we can grow our crops and that the entire, our world functions with precipitation. So a couple different types of lift precipitation. So you have, if you have a large mountain range, you'll have what is called orographic lift, where you'll have moist air coming in, approaching this mountain range, and it is kind of forced up. And as it's forced up, it condenses into a cloud, and you'll have precipitation down on this side of the mountain. But then that drier air comes down over here, leaving this side of the mountain rather dry. Another type of lifting occurs whenever you have, this is called convective lifting, where you've got your ground surface here, and this ground is hot. It is warmer. The ground here is warmer, heated by the sun. And because the ground is heated, the surface of the earth causes the moist air to rise up. And so that rising, because the hot air has increased buoyancy, and as it rises, all this air from this area rises up because of that increased buoyancy. It'll condense into a cloud, and then all that cool moisture is now up here because it is cooled as it has risen, allowing for precipitation.